Welcome to another video on smart architectural programming, and in this video we'll be going over another Blind 75 problem that we're going to solve from the LeetCode list of questions. This problem is basically the binary tree order traversal problem, and it's a relatively simple problem again, but there's a knack to it. You need to get that intuitive understanding, and this problem shouldn't pose a big issue for you to solve in your coding interviews. So first we need to basically understand is that we're given a binary tree and we need to return the level order traversal of it as a nested list where each sublist contains values of the nodes at a particular level in the tree from left to right. So what does all of this mumbo jumbo means? Like let's dive deep into it and try to get a more logical understanding of all of this text, right? So we're given a tree like this, right? Given that we have a tree like this, right? And let's use the blue color here. Given that we have a tree like this, we need to first go over through each level of the tree. This is the first level, which has this. Second level, which has the 2 and 3, and third level, which has 4, 5, 6, 7. We need to go over each of these levels, right? From left to right. What do I mean by that? So let's use another color. So we need to go over these like this from left to right. And while we're going over this like this, we need to create a list here with the value 1, right? That is what we do, right? And the values are written from left to right as we move, right? Similarly, we go to the second level and do the same thing. And let me make it a little bit cleaner. So and here we have two values, 2 and 3, right? So given that we have these two values, we write them in the list in the appropriate left to right order, and then we do that for the last level as well. 4, 5, 6, 7. So given that we have that, let's write that list as well in the given order. 4, 5, 6, 7. And all of these lists need to be combined in a single larger list, and that is the result we need to output at the end of this program. So we need to create sublists for each given level of the binary tree, and then combine those different sublists into a single larger list and return that from our entire coding logic. So that is all we need to do. Now you'd be thinking, how do we go about doing that? There's something let me actually remove all of this if I can. So the algorithm we're going to use here is an algorithm we've discussed many times, which is the BFS, or the breadth first search algorithm. So this algorithm, what it's going to do is it's going to create a queue, right? So it's going to create a queue where it keeps those values and removes them once it's adds them, basically. So within that queue, we'll have something like these memory spaces, right, which would contain different values of that it would save, and then these values will be popped off and created into a list, right? So we do, in the first level we have 1, so we add 1. Once we're done with the first level, we remove 1 and add that to a sublist as we discussed, right? So this is what we mean when we're creating a queue using the breadth first search algorithm. So again, like, this is more so programmatic, not intuitive, so I wouldn't go too deep into this. I'll just explain what's happening on the coding side to make it a little more clear as we move along. So given that we now understand that, let's move over to our code. So in this screen, you'll see that we have already typed out the solution, so you can see exactly how to solve this problem. But we need to understand exactly what we're doing. So first, we need to understand that the tree node is basically a class for creating different binary tree nodes with the value and pointers to the left and the right child node. So whatever this thing that you see here, it's always defined structure of the tree node, basically, so we don't need to define it ourselves. So then we have edge cases, right? So if the root is none, we need to return an empty list since the tree is empty. And to set that up, you'll notice that the first value is if not root, which means if root is null, then return an empty list, right? So we're done with that first edge case that we need to resolve. Then the last thing we need to do is implement the breadth first search algorithm using the first in first out queue that we discussed to traverse the tree level by level, right? So first we need to add the root node to the queue. As you can see here, while there is a queue, we need to add the root node to the queue. So we do level size length of queue, we initialize the queue, we get an empty list, then we go create a value, and then we add those values to the queue. Basically, in queue child new nodes for the next level, add nodes value of the current level, right? And then we append those values and just do that queue first in first out sequence basically. And so that is basically logically how you solve this problem. So if you run this code, you'll find that all of our cases should clear. Yep, all 3 cases were cleared. And then we submit this, the problem should be accepted. The problem was accepted, which shows you can, using this logic, using this understanding, you can solve this problem. If you got any value from this video, please like and subscribe. And if you have any questions, please let us know in the comments below so we can create a video to solve this problem. And with that, I'm going to sign off and see you in our next video. Thank you.